Hello students, welcome to lesson 20 on trigonometry. I hope you are all doing well. Good. In our previous lesson, we looked at trig ratios of angles greater than 90 degrees using special right angle triangles. We solved some examples and then I gave you an assignment. I hope you've all done the assignment. Good. We will begin our lesson today with solution to the assignment. Right. So the question, without using calculator, evaluate the following. So we have sine 120 degrees, cos 210 degrees, and tan 300 degrees. Right. So before we begin, we have to bear in mind that we were not supposed to use calculator. Right. So to start, you first of all have to look for the quadrants within which these angles will fall when drawn in standard position. So you have to know the quadrant within which these angles will fall when drawn in standard position. So for 120 degrees, it will fall in the second quadrant. 210 degrees will fall in the third quadrant, and 300 degrees will fall in the fourth quadrant. Good. Now, aside the quadrant, you also have to look for the sign of the trig ratio in those quadrants. So we know that sine is positive in the second quadrant, and therefore sine 120 degrees will be a positive value. We also know that cos is negative in the third quadrant, and so cos 210 degrees will also have a negative value. And finally, tan, we know it is what? Negative in the fourth quadrant, and so tan 300 degrees will be negative. Good. So these are the two key things you have to consider before you begin. So let's look at the presentation. Right. So we have our 120 degrees in standard position, and we learned that for angles greater than 90 degrees, we use their reference angle in determining their trig ratios. So the reference angle for 120 degrees is 60 degrees. Therefore, sine 120 degrees is the same as sine 60 degrees, and our answer is root 3 on 2. Okay, so sine 120 degrees is root 3 on 2. You can check it out with your calculator. Good. Now, the B, we have our 210 degrees in standard position, and our reference angle is 30 degrees. So, cos 210 degrees will be equal to negative cos 30 degrees, and we will be having negative 1 on 2. Right. Then finally, we have 300 degrees in standard position. Our reference angle is 60 degrees, and so tan 300 degrees will be equal to negative tan 60 degrees, and we'll be having negative root 3. Good. So students, this is the solution to the assignment. I hope you scored all. Good. Now if we're not able to score all, don't worry. Take your time, go through the solution again, and you'll be okay. If you still don't get it after going through the solution, then go through the lesson again and come back to solve the question, okay? And you'll be fine. Right. So that is about the assignment. Now in our lesson, the main lesson for today, we'll be looking at trigonometric equations. Trigonometric equations. So we'll be solving for angles when some trig equations are given. Okay, we'll be solving for angles when some trig equations are given. Right, so let's begin our lesson. Good. So trigonometric equations. Example 1. Now, the question says, given that tan into bracket theta plus 20 degrees equals 1.72, and we've been given that 0 degrees is less than theta less than 90 degrees. So theta should also have degrees. we are to find theta to the nearest degree. We are to find theta to the nearest degree. Good. So anytime you have a trig equation to solve for the value of theta or whatever angle you are to look for, the first thing is to look for the sign of the ratio. The sign of the ratio. So here our ratio is 1.72 and it is positive. Okay, so our ratio has what? A positive value. So the reason for knowing the sign of the ratio is to determine which quadrant that the angle will fall. So once we are having a ratio of positive and we are dealing with tan, it means that the value of the theta will fall in the first and third quadrant. Okay, so the value of theta will fall in the first and third quadrant. Good. So that is what we have to bear in mind. Now, after knowing the quadrant within which the theta will be, the next thing is to look for the condition, because questions at times will restrict you to only one value of theta and not the two possible values that we have seen that we'll get. Okay, so after knowing the sign, the next thing is to look for the condition, and this is the condition. This is the condition. So we've been told that theta is between 0 degrees and what? 90 degrees. So once theta is between 0 degrees and 90 degrees, it means that we will choose the value of theta which falls in the what? The first quadrant. I hope you are with me. Good. So we saw that the value of theta can be in the first quadrant or the third quadrant because the ratio is what? Positive. Now the condition here is limiting us to one value of theta, and the condition says that the value of theta should be in between what? 0 and what? 90 degrees, which means it should be in the what? The first quadrant. So with this question, we'll focus on the value of theta in the what? First quadrant, and ignore that which is in the what? The third quadrant. I hope you are with me. Good. So now let's look at the presentation. Good. So tan into bracket theta plus 20 degrees equals 1.72. So tan into bracket theta plus 20 degrees equals 1.72. So here we want to find theta. Okay, we want to find theta. So the angle here is theta plus 20 degrees. So to get that, we have to find the tan inverse of 1.72. So we're now going to have theta plus 20 all in degrees, okay, equals tan inverse of 1.72. Okay, tan inverse of 1.72. So here we will need the calculator. So let's get our calculator. Good. So now you press shift and then you press tan. You have 1.72. Then we close the bracket. Equal to. Good. So now the calculator is giving us a value of 59.8265. 59.82647997. Now here it is acceptable and appropriate to run your value to 4 decimal places. Okay, so there's no need writing all the values on the calculator. You approximate it to 4 decimal places and it is acceptable and as well as what? Appropriate. Okay, so it means that we are going to have 59.865. Because we are approximating to 4 decimal places, we have to add 1 to the 4 because the next digit or value is what? 7, which is what? More than 5. Okay, good. So we are now going to have 59.8265. 59.8265. Good. 59.8265. Good. So it should also be in degrees. So we have theta plus 20 all in degrees. So because they are all in degrees, the unit will cancel out. So now we'll have theta plus 20 equals what? 59.8265. Good. So now we need the value of theta, so we have to make theta the subject. So theta will be equal to 59.8265 minus 20. Okay, minus 20. Good. So now we are going to have, so when you do the subtraction, 59.8265 minus 20, what are we going to get? This one, without the calculator, you can still get it. Alright, so we are now going to have 39.8265. Okay, 39.8265. Good. Now bear in mind that we were told to find theta to the nearest degree. The nearest degree. So 39.8265 to the nearest degree will be what? It will be what? 40 degrees. 40. It will be 40. Because 39 is closer to what? To 40 than to any other value. So after our 39, the next value after the decimal point is 8. Okay, so it's more than 5. So you add 1 to the 9 and you get what? 40. So the value of theta to the nearest degree is what? Is 40. Good. So students, this is the solution to example 1. Now let's look at example 2. Good. Example 2 also, it says we are to find the value of x if sine x degrees equals to 3 on 2. And our condition is that the value of x should be between 90 and what? 180 degrees. 90 and 180 degrees. So as I said, the first thing is to look for what? The sign of the ratio. So here also we are having a positive value. A positive value. And we know that sine is positive in the first and second quadrant. Sine is positive in the first and second quadrant. So here the possible values are value in the first quadrant and value in the second quadrant. But the condition here is limiting us to only what? One value. So now our x is between 90 degrees and 180 degrees. So it means that we'll focus on what? The value of x in the what? Second quadrant. Good. So let's look at the solution. Right. So sine x degrees is equal to root 3 on 2. So here x degrees will be equal to sine inverse, okay, of what? Of root 3 on 2. Then we close the bracket. So x degrees will be equal to sine inverse of root 3 on 2. So here also we will need the calculator. Good. So shift sine, we need our root 3 on 2. So root 3 on 2, then we close the bracket. Good. Now equal to. Right. So here the calculator is giving us what? 60 degrees. Now this is where we have to be careful. So the calculator is not giving us the two possible values of what? Of x. Okay. Ideally, we saw that once sine is positive, we should get two values of what? Of x. One in the first quadrant, one in what? The second quadrant. But the calculator gives only one value, which is what? The smallest among the two. So here, the calculator is giving us only the one in the what? In the first quadrant, which is what? 60 degrees. Meanwhile, there is another one which is also in the what? In the second quadrant. So it means that we have to what? Use this value to get the one in the second quadrant. I hope you are with me. Good. So the calculator will give you only the smallest value, not the biggest value among the two. so which is 60. So we have to use this 60 to get the value of sine in the second quadrant. So here the 60 is an acute angle, and to get the value of x in the second quadrant, we have to use this 60 as our reference angle in the second quadrant. So the 60 degrees here will be the reference angle for our x, okay, because we are to deal with what? The second quadrant. So this 60 that the calculator has given us will be our reference angle. Is that okay? So let's see how we'll get the principal angle when our reference angle in the second quadrant is 60 degrees. Good. So our x will be equal to, so we are now determining the value since my Cartesian plane is something. Good. So here we know that in the second quadrant, this is what we are going to get. So 60 degrees will be the reference angle. Okay. So it means that our main angle, okay, our main angle will be here, from here to here. So how do we get the main angle? So we can get the main angle from what? Subtracting the 60 from what? From 180. Because the 60 plus our main angle x, let me put here, x will be equal to what? 180 degrees. So when you subtract 60 from 180 degrees, you get what? X. So our x is going to be what? 120. Our x is going to be what? 120. I hope you get it. Yes. So we'll get x degrees equals this, but because they are of what? Of the same unit, our x is what? 120. I hope you get it. Good. So you have to take note of this one. The calculator will only give you the smallest value among the two possible what? Solutions. So you have to use this, the smallest value, as a reference angle in getting the what? The principal angle. So sine x giving us √3 on 2 and x being in the second quadrant, the value of x will be 120. So let's check from the calculator and see. So when we punch sine 120 degrees, we should get √3 on 2. Good. So we are getting what? √3 on 2. Right. So I hope you follow. I hope you follow. Good, 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 good. So that is the answer for the second example. Now let's look at the final example, that is example 3. Example 3. Now here also it says find the value of x if 2 sine x degrees plus √2 equals 0 for 180 degrees less than x less than 270 degrees. So here you realize that it's not easy determining the what? The sign of what? Of the ratio. So we have to rearrange this equation so that we get it in the form where we will have sine x degrees being equal to what? A ratio. So this is what you have to bear in mind. You have to redo the rearrangement so that your sine x degrees will be equal to what? A ratio. And then you determine the what? The sign of the ratio. Okay, so let's look at it. Good. So here we are now going to rearrange. So we are going to have sine x degrees equals, so 2 sine x degrees. Now this one will cross the equal sign, so we are going to get negative √2. Okay, negative √2 because it is positive. So we have to divide both sides by 2 so that we'll have sine x degrees to be equal to negative √2 on 2. Negative √2 on 2. I hope you are following. Good. So now we want the value of x. So x degrees will be equal to sine inverse of what? Negative √2 on 2. Okay, so x degrees will be equal to sine inverse of negative √2 on 2. So here also we will need the what? The calculator. So let's get our calculator. I hope you are following. Good. So shift sign negative, so minus what? Root 2 on what? On 2. Good. So sine inverse of minus root 2 on 2. Good. Let's see what the calculator will give us. Wow. The calculator is giving us minus 40 degrees. Minus 45 degrees. Minus 45 degrees. This is strange. Oh, yeah, it's very strange. How can we get a negative angle? Okay, don't worry. I will let you know how we'll deal about this, or how we'll go about this one. Right, so sine inverse of negative root 2 on 2 is giving us negative 45 degrees. Negative 45 degrees. So how? Right, now we have to know why we are getting what? Negative 45 degrees. Why we are getting negative 45 degrees. Now let's come here. Now when we did the rearrangement, we got sine x degrees to be equal to negative root 2 on 2. Okay, negative root 2 on 2. And we know that sine is negative in the what? Third and what? Fourth quadrant. Sine is negative in the third and fourth what? Quadrant. I hope you are with me. Good. Sine is negative in the third and fourth quadrant. Good. Now the calculator is programmed in such a way that angles below the x-axis, okay, are in negative, and then angles above the x-axis are in positive. Okay, so that is how the calculator is programmed. So if you have angles above the x-axis, sorry, it will be in positive values, and angles below the x-axis will be in what? Negative values. Okay, good. So that is what you have to bear in mind. And we know that sine being in the third and fourth quadrant will be below the what? The x-axis. So that is why the calculator is giving us negative 45. Okay, good. But we want a positive value because the range of values of x was not negative. So how do we go about it? Good. And also, let's check the range of values that we were given. Now, our x should be between what? 180 degrees and what? 270 degrees. So, which means that we should focus on the one in the what? In the third quadrant, and not what? The fourth quadrant. Okay, good. So here, sorry. Here also, we are to use the 45 as our reference angle, okay, in the third quadrant to get our main angle, that is the principal angle. So we use the 45 as our reference angle in the third quadrant to determine the value of our principal angle. So let's see. So you will need your, let me use, my diagrams are not working for me. All right. Good. So we have this as our Cartesian plane, and then in the third quadrant, 45 degrees, okay, 45 degrees will be our reference angle because the calculator gave us what? Negative 45 degrees. So 45 degrees is what? Our reference angle that we are to use. And because we are in the third quadrant, this is where it will be. If we are focusing on the fourth quadrant, it would have been here because negative angles are in the clockwise direction. Good. So we will use this 45 as our reference angle in determining our principal angle. Right. So let's see. So now from the x-axis, positive x-axis, here, this will be our principal angle. Okay. So here is 180 degrees. Okay, so it means that to get the principal angle, we have to add 45 degrees to what? To 180 degrees, and that will give us what? Our principal angle. Okay, so what will 180 plus 45 give us? To give us what? I think 225. Okay, 225. Good. 225. So it means that our x, okay, our x will be equal to what? 225 degrees. Our x degrees will be equal to what? 225 degrees. And finally, our x will be what? 225. Our x will be what? 225. 225. Okay, so student, this is how we look at this one. So getting a negative value of angle with sine inverse, it means that it's below the x-axis. It's below the x-axis, and we use the 45 as what? As our reference what? Angle. Okay, good. So we can also check from the calculator. We can also check from the calculator. Right. So we'll use this one. Okay, sine in place of x, and we should get minus root 2 on 2. So sine 225. You close the bracket. Let's see. Good. So the calculator is giving us what? Minus root 2 on 2. Minus root 2 on 2. Good. So it means we are right. So students, that is the solution to example 3. That is the solution to example 3. Now, I have example 4 here, but I want you to do it yourself. Okay, try the example for yourself, and let's see what you get. Try the example for yourself. So pause the video, solve, and then get the value of p for me. Okay, so let's look at the solution for example 4. So here also you have to rearrange. When you do the rearrangement, you are getting cos p degrees equals half. So you need the what? The cos inverse of half, so that you get the value of p. So let's see what the calculator will give us. So shift cos inverse of 1 on 2. Good. So let's see. Good. So the calculator gave us 60 degrees. 60 degrees. Okay. Now here, the range of values is what? Between 270 and 360 degrees. So which means that it should be in the fourth quadrant. In the fourth quadrant. And here also cos p is what? Positive. And we know that in the fourth quadrant, cos is what? Positive. Okay. But the calculator gave us only one value, which is what? The one which is acute angle. That is the smallest among the two, because cos is positive in the first quadrant and in the what? Fourth quadrant. But the calculator gave only the smallest value, which is what? 60. So we have to use this 60 to determine the value of what? Of p in the what? In the fourth quadrant. Now the 60 here will also serve as what? A reference angle in the fourth quadrant. So here our reference angle will be 60 degrees. Okay, so now we want this value. Our main angle p is from here to here. Okay, so it means that we have to subtract this reference angle, which is 60, from what? 360. Okay, from 360 to get our p. So p is equal to 360 degrees minus 60 degrees, and p is what? 300 degrees. So the answer for p is 300 degrees, because the values or the condition is that p should be between 270 and 360. Good. So students, this is the end of lesson 20. Now I will give you some assignment for you to try so that you build your confidence. Okay, and make sure you do it. right? So there are two of them. This is the first one and this is the second one. So make sure you get the two, first one and second one, right? Now our next lesson will be looking at angles of elevation and depression. So we are starting everything from beginning. So we'll begin lesson 1 on angles of elevation and depression. So stay tuned, okay? So till we meet again, revise, read ahead. Bye.